Okay, so hello everyone, welcome. My name is Marcilio Mendonça. I'm a senior DevOps consultant with AWS. And joining me today is Mauricio and Capiz from the Aldo group and Jane from AWS. So we're here today to tell you about a very nice customer obsession story. So Aldo is a retailer with over 2,000 stores across the globe, across 100 countries. So it's really a global operation. And they've used AWS to really transform their customer experience. So that's the story I'm going to tell you today. So I'm super excited to have Aldo here. So before Aldo comes to the stage, I would like to share a little bit of the history on how the story that we're sharing with you today happened. So then Aldo will join the stage and share a little bit about their business, their key business drivers, and how they built the solution that they have today, and some of the lessons learned as well. Okay, so in 2017, we engaged with Aldo, so AWS and Aldo engaged together. And then Aldo had two main technical challenges that they wanted to solve, right? They wanted to address two technical challenges. So one of them was the fact that their mobile application had too much knowledge of the backends, right? So very coupled with the backends, doing data aggregation at the client side. So they wanted to build some abstraction layer to separate, the backend from the various the mobile application from the various backends. So that was problem number one. Problem number two was they needed the associates in the store, in the Aldo stores, to communicate in real time. So basically, when a customer comes to a store, let's say he picks up a pair of shoes, but he wants a different color or a different size. So the associate that's helping the customer will then send a message in real time to another associate that's picking up products for customers, and then bring that shoes to the customer. So you can see how time sensitive it is because the customer is actually waiting. So you don't want to give them a bad customer experience. So Aldo needed to have real-time messaging at scale because they have 2,000 stores across the globe. So those were the two main challenges that they had at that time. We're talking about 2017 here. So we built several POCs together to show Aldo the capabilities we had at that time. So we used things like API Gateway and Lambda in IoT for real-time transactions, for example. The POCs were successful. We showed the capabilities of the platform to Aldo, and we transferred knowledge to them. But at the same time, it was super important for AWS to also hear from the customer. So we're a very customer-obsessed company. So we gather a lot of feedback, especially in terms of real-time messaging. How can we enable real-time messaging for mobile applications in a simpler way? So the question that we had was, how can we make this even simpler? So move forward to 2018. Aldo told us we're ready. We're ready to make these POCs into production. So let's make it happen. So we engage in an agile fashion. So some consultants from AWS, some devs from Aldo. And in a couple of months, we worked together using a service called AWS AppSync that was in the works at the time. So AWS AppSync is a serverless mobile backend that was strongly influenced by customers, including Aldo. So the feedback that we gathered in 2017, especially in terms of real-time requirements for mobile apps, was really critical to make sure that we had a service that attends better our customers. So it was just natural that Aldo would become one of our first customers, given that they had a huge influence in the product. So they became an early adopter of AWS AppSync in beta in early 2018. And the interesting thing was that we used AWS AppSync for the two challenges that I just mentioned, right? So a single platform was all we needed to address both of their technical challenges. So we used GraphQL and AppSync to build an API layer to decouple the mobile applications from the backends. And at the same time, we use AppSync subscriptions to enable real-time communication between associates in the stores. So it's a super interesting solution and simple at the same time, using AppSync for both cases. So Aldo became a public reference for AppSync when we launched this year in 2018. And they started rolling out the solution just a few months ago, very successfully in a couple of stores. We were just speaking yesterday, and they said that Black Friday and Cyber Monday was smooth. So that's awesome. And AppSync continues to evolve, right? So I'll let I'll invite Capis to the stage here so that you can hear directly from Aldo about their key business drivers and how they use AppSync. Capis?
Hello, everyone. My name is Capis Valipro. I'm the software dev manager at the Aldo Group. Today, I'll tell you a bit about who we are and what we do at the Aldo Group. So before I start, by a show of hands, who has heard about Aldo? Oh, it's not too bad. So just like Drake and Justin Bieber, we're from Canada, Montreal to be precise. We scaled out to over 100 countries in the last 40 to 50 years. We have close to over 2,000 brick-and-mortar stores, 800 which are corporately owned. We have over 20,000 associates all over the world. These guys are the ones that help us maintain almost over 260 million in-store visits per year. It's a huge operation. So if you look to the left, that's our biggest store in Dubai. To the top right is a store in Boston, a bit more techy. To the bottom right is our newest store in Los Angeles. So the founder of Aldo, Mr. Aldo Bensadoun, was a people person. He valued 3 core values: love, respect, and integrity. He made sure whatever operations we do, this is key. Some facts to demonstrate this. Over 60% of our workforce are women. Even in IT, the ratio is pretty high. 98% of our shoes are PVC-free. Aldo also pays his employees to do volunteering hours. So 2017 alone, we've committed to over 5,000 hours of volunteering time. Last but not least, Aldo is the first fashion footwear retail company to be carbon neutral. We're recently certified by the South Pole organization because we were able to offset all our carbon emissions through our head office, our stores, and our distribution center. Why are we able to do this? The main reason is because we are the creator and operator of all our products. We own 2 main brands, Color Spring and Aldo. We also have another brand called Global, where we sell other retail brands. Being in the business for over 40 to 50 years, we've become a specialist and also wholesale, also a sourcing partner for other companies. But recently, we've seen things have started to change. Consumer behaviors have changed, and it's hard to keep up. If I were to sum it up in one word, it's technology. So Aldo in the last few years has spent a lot of money into digital technology, and we still do to date. And our main focus, our main goal is to deliver a better customer experience, eventually a frictionless experience. So for example, this year alone, we redid Color Spring redesign on the new architecture. We leveraged Lerna for our monorepo. We implemented Fastlane to get out our iOS application out frictionless, in a frictionless fashion. Hybris as our e-com solution, and many more. Here I'll talk about a little showcase to demonstrate what we worked on this year/last year. On the left, Aldo partnered up with 5 artists internationally, and we created custom shoes. And we wanted these PDPs to stand out a bit more, so as you see, they have a lot of animations, very responsive, quick to market. In the middle, this is our redesign we worked on this year, Color Spring, on our monorepo, reusing the existing architecture that we did for Aldo from the year before. On the right, it's Aldo. We have AA accessibility and the full responsive, all that fancy stuff. So that was all the web projects, but what about the in-store applications? So for us, we reached out to Amazon because we wanted to be fast to market, cost to be less, and we wanted to fail fast. If it works, it works. So this is where we met up with our buddies from Amazon, and this is a use case I'm going to go through quickly. So we have an associate at store, and the customer wants to try on a shoe. We're able to tell the customer right away if there's her size available in the store. If not, we're able to even suggest other products within the store. So while we make the request to the runner in the back, we can serve 2 or 3 other customers at the same time. So the customer experience we've had this application before, but we wanted to improve and make it better. As much as I would love to get into technical details, I'm going to let Mauricio take over from now. Thank you.
Hello, everyone. My name is Mauricio Perez. I'm a solutions architect at Aldo, and I'm going to be talking about the different services that we use in this architecture and the reason behind them, and some of the experiences and challenges that we faced. This is how the architecture used to look like before, when we were back in 2017. We have multiple mobile applications that we use with our store employees. These applications were using multiple backend systems and multiple service endpoints directly, so that was really complex to maintain and to manage, and you can imagine the complexity of managing all these integrations. All the aggregations were done on the application level, so that's why performance was limited too. Within the systems, we have our e-commerce platform where we have our product catalog, shopping cart, and payment integrations. We have our inventory management system with product availability. We also have our human resources tool with information about our employees. And we also have a CMS tool with marketing content. So these are our main tools and main platforms that we have at Aldo. And instead of leveraging their capabilities and features, what we did was what we had was a different layer where we started adding more features to it. So we had that layer in the middle where we had a product replica with some additional features like similar styles, related products, and search. We also were managing in that layer the notifications to push messages back to the devices. And finally, we had a real-time database in a different tool with a different vendor that was managing subscriptions. And that also required another tool to control those statuses to make sure that the transactions were always in the right place. So that was how it used to look like. We were not leveraging our tools. We were creating more and more dependencies between the apps and the systems, and dependencies also between the systems themselves. So performance was limited, multiple communication protocols, authentication systems, caching strategies, all the aggregation of the application, so performance was not that great. Scalability was limited. We depended on the vendors and their infrastructure components and data centers. So for periods like Black Friday and Cyber Monday, we rely on them to provision all the infrastructure required for this to work. Troubleshooting was really challenging because investigating where the problems were, that took a long time and involved a lot of people. So that's why it was very difficult and challenging to find the reason for a problem specifically. And at the end, it was just generally complex and way too many platforms and tools. Now, what we were able to achieve with this serverless architecture was to have one consolidated layer of services for all our mobile applications. And this layer is truly leveraging the features and capabilities from our systems. We're hitting those systems directly, and we're exposing all their logic through this layer, so our applications are no longer tied to these tools, which is very important for us because if in the future we need to replace one of them, we will be able to do it without impacting the applications. Also, the maintainability is higher because now we're using GraphQL, so all of our applications are using the same language to query information from this layer. That makes it so much easier to exchange information, exchange information not only between the applications in the backend, but also between the applications themselves. Now, these serverless services are by default full scalable and high available, so we're no longer worried about high periods like Black Friday or Cyber Monday. Actually, we just did last week, and we had no SEP 1s or SEP 2s, so we're pretty happy about that. And one interesting thing that we did was that we were able to use all these lambdas and AppSync endpoints that we have in this new architecture. We were able to integrate all the log messages with our tools, logging tools that we have by default, that we use by default in all of our systems. We use tools like Kibana and Sumo Logic. We were able to send all the logs from these serverless services to our tools so we can monitor them in the same applications we use today. And of course, we have less vendors, less platforms, less technologies, less integration, so it's easier to manage. Now we're going to start taking a closer look to the architecture and the different services that we use. In the center of the architecture, the main component is AppSync. That's what we're using for queries, mutations, and subscriptions. So basically, queries means retrieving information from our systems. Mutation is pushing data to them. And subscriptions is to, as Capis was mentioning before, is to enable that real-time communication between the store employees, the consumers, and the backend system too. AppSync is aggregating data from Dynamo and from Lambdas. Those are two main sources. In Dynamo, we have all the transactions and the different status. And Lambda has two main functions. The Lambda functions have two main purposes. One is to retrieve information from our backend systems, from our corporate systems. So as you can see now, we're leveraging them instead of replicating their features and services. We're doing things like product lookup, search, inventory lookup, related products, other categories, and all the different services that we use to create the features that the applications are displaying to our employees. That's the main purpose of the Lambdas. And the second one is to actually control all the status for the transactions. So Lambdas are in charge of making sure that those transactions are in the right place at the right moment. Depending on the flow and the status of those transactions, we push notifications back to the devices to make sure that no event or no transaction is getting lost, because that could mean that one of our consumers is actually waiting for a pair of shoes for too long, and we don't want that. So it's important to keep those devices up to date all the time, and we're using Pinpoint to manage those notifications that we're pushing back. Last but not least, we have Cognito. Cognito, we are managing that for authentication, and eventually it's going to be single sign-on too for all mobile applications. Cognito, and that's one of the cool aspects of the solution, Cognito and the users that we have in the pool, they're managed automatically by our broker. We have a middleware layer in our corporate systems, and we're managing those users directly through API. So every time there's a new employee, we get it directly from our human resources platform, and we create it and update it in Cognito directly. So that's automated, and we don't have to wait for a manual process to occur. Now, from a security point of view, our devices and our applications are using basically username and password to authenticate, but we added an additional security measure that is basically an API key that we release. And those API keys are stored in Service Manager. We're evaluating that service right now. We were using stored parameters before. And basically, the idea is that those keys will be validated by a Lambda function. And the Lambda gets triggered by Cognito in the pre-authentication trigger. So that's just to make sure that our devices are authorized to use our endpoints. So that's the first endpoint that our applications are hitting, the Cognito endpoint for out. Then the second one is AppSync, but we created our own subdomain for AppSync. So that's why we're using Route 53 and CloudFront to route to those AppSync endpoints. But that also gives us the possibility to have a canary, or to manage canary deployments, so we can actually deploy multiple AppSync stacks and route the load of concurrent requests to them differently. We can, for instance, send 90% of the load to the production endpoint in AppSync, and then 10% to the new endpoint that we want to test out during a specific event or a feature that we want to try it out. So that's what we're accomplishing with Route 53 and CloudFront. And just as an additional security measure, we added also some geographic restrictions to make sure that those endpoints are only called from the countries where we have stores and devices. Finally, there's another endpoint that is not visible in this diagram, but it's the subscriptions endpoint. AppSync is using IoT MQTT queues for subscriptions. So your applications will always have three endpoints: Cognito, AppSync, and subscriptions. Yes, I think it's worth mentioning that. And of course, we're using IAM extensively to control all the policies and roles so that these services can talk to each other. Now, this is really important. This is what Marcilio was mentioning at the beginning. This is what enables real-time communication between our employees and the devices and the consumers. So just to walk you through it, when that consumer requests a pair of shoes, one of our store employees will go to that consumer, will scan the shoe with one of our applications, and it will create a request. That request goes as a mutation to AppSync, and then AppSync sends that mutation to a Lambda resolver. And the reason for having Lambda in the front is because we want to make sure that the status are correct. So we don't want to have a transaction that was claimed by two employees at the same time. We don't want to reprocess a transaction that was already completed. or things like that. So that's why Lambda is always in front, controlling those statuses. Also, well, after that, Lambda is going to create the transaction in Dynamo, and it's going to retrieve a subscription back to the device. Now, the employee is going to receive all the different events related to that transaction specifically. So he can know when another employee claimed the transaction, when the shoes are ready, or maybe if the shoes are not available, he'll get a message right away because he's subscribed to that transaction. We have basically two types of subscriptions. It's one for the employee that is creating the transaction, and another one for the runners or the employees that are in the back store. And they're subscribed to all the transactions in the store so that they can take care of those transactions. So basically, that Lambda function from the beginning, depending on the status, is going to trigger other actions, other steps. It depends on the status of the transaction. So in this case, we could trigger another Lambda. We use SQS for that. We were using before SNS, but after SQS was released and integrated as one of the triggers for Lambda, we started using them. And it decouples the logic and between the Lambdas and the different steps, so that's why we use SQS. And then, for instance, we could go and retrieve more information about the product and enrich that information in the transaction in Dynamo. Normally, what we do right after creating a transaction is push the notification, so that's the Lambda on top. And that Lambda is going to, through pinpoint, is going to send a notification to the devices that the runners are using to make sure that they get that transaction right away. Because, again, the consumer is waiting for it, so we don't want to take too long to execute that. So the devices might be logged, the devices might be away charging. So what we want to do is make sure that they really see that transaction right away. So normally we reproduce the sound to get their attention. And I think at some point we were playing with the lights in the backstore to really capture their attention and make sure that they're not losing that transaction. Then after the runner accepts the transaction and take the pair of shoes and take them forward to the front store, the initial employee will get that message and he will know that the pair of shoes are ready to be delivered to the hands-on to the consumer. I wanted to mention that during this the implementation of the architecture, we had many challenges related to the reliability of the connection on the store. You know, our stores in the mall, there's so many different Wi-Fi endpoints using similar channels and frequencies. So normally, you will expect to have disconnects between the devices and those connections. So it was really challenging to overcome this difficulty. But we worked very closely with AppSync and our development team to make sure that those challenges were overcome. And now I'm very proud to say that our development team at Aldo was able to, with the help of course, of the AppSync and team, to make that SDK more reliable. And it's really an advice or a suggestion to you guys is if you ever have a challenge, don't hesitate to contribute with Amazon and give them feedback so that they can make these services even better. So right now, after Black Friday, we feel very confident that this is going to work very well because we're already using them during our busiest time. So we're very happy about that. From another point of view, we're calling the endpoints from our backend systems using Lambda resolvers. We're doing calls like product lookup, inventory lookup, store lookup as well. Those are some examples. But as you know, when you're using Lambdas that are going through a VPC connection, you always have to worry about cold starts. So specifically what we did was to create our own warmer, or one Lambda that we call from schedule rules and CloudWatch. And that one Lambda is the one in charge of calling our endpoints, or functions, multiple times, because we didn't want to have just one instance of our functions available. We needed at least, 30, 40 instances of our Lambdas available so that they can take care of all the loads and requests from our different stores and employees. So we had to create that Lambda warmer, and the function for that is to call those, to ping those Lambdas in multiple times at the same time asynchronously. And it's important to mention that if you want that to work, you need to add some sort of delay in the ping handler of those functions, because if you don't, that ping handler is so fast that one Lambda, one instance can take care of all the pings from the warmer, so you're not achieving what you're trying to do. So what we did was add that delay, in the handler, and that's forcing Lambda to create more instances. So now we have enough functions to take care of all the requests. Also, whenever possible, it's a good advice to use caching. We started using caching in the Lambda functions directly, but we're moving into a centralized caching solution like Redis and Elastic Cache. These are some of the examples from our queries and mutations. As you can see, this is GraphQL. So now there's some advantages because our applications can decide which information those applications are interested in. They don't have to get the full payload from the services from our backend systems. We can filter that for them, for the apps. And these kind of queries can be used not only to talk to our backend, but they can also interchange those queries between the apps, and they can talk to each other. This is a standard language, so it gives us more flexibility and maintainability. And as you can see, this is a query to retrieve information about one of our products. So we're sending the store ID, the SKU, the country, the brand. We call our brands a banner, but it's a brand. And the language, so we can retrieve localized information. And the app is specifying that it's interested in the style information and the different attributes that it's looking into. But if we want, we can add inventory there as well, or similar styles. I mean, it depends on whatever we want to do, whatever feature we want to do. But it's so much easier now with GraphQL. In the mutation, we see that we're sending not only the necessary data for the actual transaction, but also data for analytics, in case you're interested in keeping statistics about the employees, how many transactions they're doing by day, and what are the styles that are more frequently requested by your consumers. So that's really interesting too. Now, we use CloudFormation extensively. So basically, this was to enable the automated deployments of all of our different services. We have the stacks for CloudFormation stacks for all of the main services. And just to give you a reference, our AppSync stack is getting the Cognito ID from the Cognito stack as an output parameter, is getting the list of tables from the Dynamo stack, the list of functions from the Lambda stack, and so on and so forth. So as you can see, we have connections between our stacks, and we can deploy them not only in an automated fashion, but also independently, because our developers are normally using the Lambda in the AppSync stack, sometimes the Dynamo stack as well. But the VPC, the Cognito, NIM, or Route 53 stacks, those are not changed that much, and those are managed by our infrastructure team. So that way we can work, we can collaborate, but we're not stepping on each other's toes when it comes to deployments. Now, we wanted to share some of the lessons learned about performance. That was one of the biggest reasons to move into serverless, to have a better performance. So in terms of Lambda functions, suggestion is to play with the RAM memory assigned to those functions. It's important to do that function by function because it really depends on the kind of query those functions are doing, the kind of systems they're aggregating, if they are doing that. So you will see that the higher the memory, the higher the CPU, so they're going to be faster. But at some point, that relationship is going to be flat. So you're paying more, but you're not getting a better response time. So at some point, you have to find a sweet spot between response time, memory, and cost. So that's really important. Of course, you have to keep an eye on the warmer. You need to keep your lambdas warm because in our case, we're using a lot of VPC for those lambdas to hit our backend systems. So you need to have that strategy about warming those lambdas and keep them available. But once you have a lot of lambdas, you might be hitting an error in terms of limits, because by default, an account can have 1,000 concurrent lambdas. I don't know if that changed. That might have changed recently to 2,000, but that was the limit before. And it's a soft limit, so we require our production environment to be increased. And that's how we were able to have enough lambdas to take care of all the requests from our consumers. Also, if it's possible for you, use Dynamo resolvers. It's so much faster. Of course, you don't need to go, if you're using Lambda functions that reads information from Dynamo, you no longer need a VPC, so the cold starts are basically no longer an issue. if you're able to push the information from your backend systems to Dynamo and have your Lambdas querying Dynamo directly, that's a lot faster and better, if you can do that. And of course, if you have a lot of Lambdas reading or writing into Dynamo, you have to keep an eye on capacity. Because if your capacity is too low, you might get throttled. Your Lambdas are going to get throttled, and you're going to end up affecting your consumers and their experience, because those Lambdas are going to take a long time. Also use caching as much as possible. We're using caching from our product catalog or store information. But for our inventory lookup, we cannot cache that because it has to be a real-time query. So use it as long as it's possible. That's a good lesson learned, is that when we were monitoring only our Lambda functions, all of them were performing under our threshold or target, which was 3 seconds. That was our objective initially. So we were happy about the Lambda functions, and we knew that they were performing well. But we started to notice that during our tests, the application was taking a long time to respond. And we were only able to find this when we started monitoring AppSync separately, because the Lambda functions are not going to give you the cold stars visible in the Lambda metrics, unless you're using something like X-ray or something like that, but we weren't. So we only realized that we had cold stars when we were monitoring AppSync separately. So that's a good point to keep in mind. After all this implementation, what we got out of this project was performance. Again, this is the most important part for us. Performance is so much better now. All of our applications are responding way below our target or threshold. 3 seconds is what we wanted to have before we started the project, but our Lambdas are responding a little faster, and our AppSync endpoints are retrieving the information much faster than that. Even during Black Friday, we were able to see that this was behaving really well. So we're confident and happy about this. Maintainability, now all of our applications are using GraphQL. We have 2 applications in production right now being tested in our stores, and we're building some others more, but we're going so much faster now because we have that backend layer that we can control and evolve. Now we have also a single sign-on platform, so that's even going to make the usage of this application so much easier for our employees, because they can share credentials and sessions between these applications. Scalability, we don't have to worry anymore about provisioning infrastructure components or dealing with special events like Black Friday or Cyber Monday, where you need more and more infrastructure. Now we just delegate all this to AppSync managed services, so we don't worry about this anymore. And again, during Black Friday and Cyber Monday, the services were available and they were responding quite fast, so we're happy about that. And the availability is built in the serverless services, so one less concern from for our different teams. And again, one of the things that we got out of this project, and that's what I had for you guys. I'm gonna leave the stage now to Jane. She's gonna talk more about the lessons learned, and that's it.
Thank you, Mauricio. This is why we love having customers come and tell stories, because just wonderful story, wasn't it? Even I'm learning something every time I hear the deck. Hi, I'm Jane Shan. I'm from AWS Professional Services. I had the pleasure to work with Aldo and our fellow consultants on this engagement, working with AppSync. So today I'm going to talk about the lessons learned during our engagement. Obviously, you've already heard a lot from our lovely friends here, but I'm going to give you a little bit more deep dive into AppSync and GraphQL. How many have you worked with AppSync and GraphQL yourself or done some examples? All right, good, a few hands. Okay, so a few things. So number one is, because you're using AppSync, AppSync is, we call it managed GraphQL service. There's some advantage of GraphQL you can take advantage out of the box. So I hear stories about REST versus GraphQL. Benefit of a GraphQL endpoint is you have one single endpoint, which does not change much. And your client, either a web or Android or iOS, can shape the query so that you only ask for what you need. So that means you can really enable your developers to work quickly, iterate quickly, and build prototypes and change how you query the data without really bugging the API developer. Say, hey, can I have another API endpoint to get another query, another item, and can I have another one because I need 2 more fields? So we really felt the benefit of that because I got some Aldo developers sitting here. One day a developer will come to me and say, I want to know the color of my shoes because your API didn't have it before. So like, here, one more property in my schema, there you go. And then I really don't have to create an endpoint, deploying it, and then make it live. So everything was ready, just easy as that. GraphQL schemas, because again, you have one single endpoint. You have one massive schema, or small schema. You need to make sure when you design it, it's flexible enough so you can keep building on top of it. So we have learned something. So we start with a few types, and then a few mutations, and a few subscriptions. So for example, we can have a mutation called update transaction. So this is when a store employee in the back has picked up a pair of shoes, say, I'm ready, I can bring it to the front. And he's going to say, I'm going to update this item. But that mutation itself, you can say, I'm updating because this is my employee ID, this is the time I'm picking it up, and this is new status. So that's 3 input parameters in that mutation. What if you want to say, I want to add another parameter in my mutation so that I want to see, just in case, I want to know who I'm giving it back to. So now that's 4 parameters. The mutation gets bigger and bigger and bigger, so it's really not sustainable. So input type is something we didn't know at the beginning because we're all learning GraphQL. It was new, AppSync was in preview. But input types is really useful that it's encapsulating all the fields so you don't have to keep changing your methods. Same as in Java or any object-oriented languages, input type is a pretty good way to wrap all your properties in one type, and you don't have to keep changing it. Another interesting thing we learned was fragments. It's more about how to consume your schema from your client. So imagine if you want to request your shoe size and color in 2 different queries. You don't want to really repeat that every single time. So you can use a fragment so that you just say, I want to use my shoe style fragments in this query and use it again. Here's the definition of this query, this style, which is color, size, or whatever. Then really reduces code duplication in your client code. So highly recommend you check out fragments. At Amazon, we usually start with an MVP model, minimal viable product. We always say start small and iterate, build on top of it. Same with your GraphQL schema. Start with something small, because it's much easier to add new fields than taking it out, right? Because your developer is going to say, I need this field, and you take it away. Oh, it's broken. So start with something that works with your client app, and then build on top of it. Last point is keep your client logic light. This is really the benefit you have with serverless applications. So for example, when Mauricio mentioned the little checkered flag, I really like that. The race condition, it used to be handled in the client app, on the iOS app. When something happens, the client is managing it locally. But now we can actually have the luxury or convenience to put it in the Lambda function, so the Lambda can perform in the back. Now it really takes away the processing power in your client app. It saves your battery, saves your bandwidth. It's probably easier and faster. So we always recommend keep complex logic in the backend if possible. Another thing to add here is if you do have piece of logic that might change frequently, put it in the backend. Let your API handle it. Let your Lambda handle it. So you don't really have to publish a new version to the Play Store or the Apple Store. It's just too much trouble for your customer. So this is more of a general idea of how to go live for production. Our engagement was about 2 months long. So even near the beginning, in the middle of the first month, we started thinking about load tests. Aldo has 2,000 stores across the globe. How many concurrent users are going to be there using our service? So we estimated the number. We started load testing pretty early. So we wrote Mauricio wrote some test suites to hit the endpoint hard, and then just see how everything responds, how the whole stack works. So we definitely hit some limits. Like he mentioned earlier, Lambda concurrency limit got hit pretty quickly. So you can contact AWS support to make it bigger. We also ran into DynamoDB table read and write capacity, started seeing lots of throttling errors. So auto scaling at that point wasn't fast enough, but I was very happy to find out yesterday, if you guys went to the keynote, that there's DynamoDB on-demand capacity, which I wish they had it earlier this year. So then this problem would go away. Test app thoroughly to see how it handles errors. So if there's a throttling error, what are you going to do about it? If something, say your backend doesn't give you the data you want, if it throws a null in the response, what are you going to do about it? GraphQL has a really cool feature that REST doesn't support. It's called a partial failure. So imagine, if you guys know the idea of GraphQL is, if you have these many fields that can come from a DynamoDB table, these many fields coming from Lambda function, they're hitting two different backends. If one fails, the other one succeeds, you're going to get a response of 200. But the first half is going to be the valid values. The second half is going to be errors. So what are you going to do when that happens? So you can, in your client app, you can say, OK, this half is not working, either because your backend is busy or it's being throttled. You can implement exponential backoff or just try again, maybe give it 10 seconds. So you can really tailor your client application to see how you're going to retry if necessary. Another thing about our test, because the stores in big malls, small shops, different Wi-Fi connectivity, if you make a query, it fails because Wi-Fi is not there, what are you going to do? The SDK is handling a lot of that for you already, thanks to working with Aldo and AWS teams. But just test thoroughly in case something happens, and figure out how to handle it yourself. This one, Mauricio already mentioned a little bit. It's very, very important. I know we as developers ourselves, we love to write code, we love to implement features, logging, monitoring, second thought. But as a production app, it's very important to think about what metrics you want to monitor, to measure, what kind of alerts you want to set up when things do go wrong, what kind of dashboards you want to set up. And if you care about performance, in this case, you don't want customers to wait for your shoes to come out, set up benchmark code in your code to really measure performance. So here are some charts we measured. This is actually, thanks from the team, caught directly from live action, some diagrams. You don't have to look too carefully into it because it really aggregates a lot of the calls. One thing I do want to point out, as Mauricio already mentioned earlier, you see that little orange spike in there, the second diagram? It's the AppSync API call taking a little bit longer. But if you look at the Lambda function, they're doing just fine. There's no spike in there. So this is the piece where you monitor them AppSync call and Lambda call separately so that you realize, why is AppSync call taking longer, but Lambda's OK? Because this is a VPC, Lambda function attached to VPC. Because of the ENI creation, all the things, it's actually a little slower. That's the cold start we're experiencing. And that's why a warmer is important in this case to mitigate that. The third chart is a little bit example of our DynamoDB invocations and how it's hit. I saw the diagram from Black Friday. It's like phew on Friday and then Monday again. So it's actually pretty cool. Another one is, I wanted to put a meme in this deck, but didn't. It's called I don't test in production. Sorry, I don't do testing, but when I do it in production. Try to test it, if you can, in an environment very similar to production. So in Aldo's case, we had 5 pilot stores. Yeah, 5 pilot stores in Montreal, in Canada, that has various type of Wi-Fi connections. So because of that, we were able to catch a lot of issues we're not able to see when we're just running everything in the lab or in the office. Wi-Fi is being a big issue. Training the associates, maybe, not really an issue. But because of that, we're able to really address these issues early, got the AWS service team involved, so they can be solved before we start pushing to more stores. This one is less about AppSync. It's more about general development of any project. So as consultants, when we go on site, we say we deliver the product, we implement the features, we work together, but we also try to make sure if you want to deploy everything, turn that into code. You want to deploy your Lambda function, AppSync APIs, turn everything to CloudFormation code so that you can automate your infrastructure provisioning and deployment. You can easily move it from account to another account. And as a result, each developer can actually have their own sandbox environment. So we actually did this. So I have my own sandbox environment. Alex would have his own environment. And then if I break something, I don't get Alex screaming at me, why is it broken? So each of us have our own separate stacks of AppSync and Lambdas, and then we make changes ourselves, and then we push and share it afterwards. This is very important. As we say, AWS is always evolving. We're innovating at a very fast pace. Things always change. So in February 2018, AppSync was in preview. A lot of things were not available, but we were able to use available tools to do what we need. So for example, if CloudFormation wasn't there, we had a nice batch script that helps us deploy our things. We need to handwrite all the GraphQL statements, like that one Marcia showed earlier. And then we needed to use a NPM tool to generate clients' strongly typed objects. So that's there. But obviously it's not ideal. So the whole team engaged with the team in Seattle and the AppSync team, and then provided feedback. It's an ongoing process. Actually, I think they still have weekly sync meetings right now, just to provide feedback and drive features, because roadmap items are really, we listen to what you tell us, and then we implement them. Just a little plug here. AppSync just has a new feature came out, I think, last week called Delta Sync. We really thank Aldo for being the main force behind that feature, because Delta Sync, that's really the use case we needed here. And we're able to go live with that feature thanks to Aldo's help. And new tools and features, because things are always coming out. Even I'm learning myself, keynotes yesterday, there's so much to learn. Stay informed, and when they're available, you can start integrating it. So for example, we knew CloudFormation is coming. So we made it the way that so you can swap out the batch scripts when CloudFormation is ready, put it back in, and the whole pipeline just works just all right. So as that, this is something I wish we had in February 2018. I wanted to talk about a little bit about the Amplifi CLI command line interface toolchain. So have you guys heard about Amplifi? OK, sounds great. So Amplifi is we call it really the new starting point. If you're starting a new mobile application, again, be React.js, React Native, sorry, Android or iOS, start with Amplifi. It really helps getting a project up and going very quickly. For our specific case, Amplifi gave us some really powerful tools. So first one is GraphQL statements can now be generated based on your schema. So for example, if I have a type called style, style has a shoe, style SKU has a color, has a name, has a gender, is a girl's shoes or a women's shoes or men's shoes. Amplifi can take that schema and dump out the queries, mutations related to that one type. So now you don't really have to manually craft, say, here's my query, I want to get it all. This is all able to generate for you with one command. GraphQL is a strongly typed language, so that if you're running, say, iOS, again, iOS, Android, or TypeScript, you need to have strongly typed client schema objects. So for us, for iOS, we had to use the NPM tool, which is deprecated now. You can use Amplifi to generate these objects and then dump it into your project. It works out quite well. So how to do it? Here's some command lines. Because it's a CLI tool, you install it onto your CLI. You call Amplifi init, create a project. You say Amplifi add API. This will give you the GraphQL API. When you're doing this, you can actually, there's an option in there. It will say, do you want to generate all your statements and queries? You can say yes. Or if you didn't do it, you can add code gen afterwards, which always gives you all your generated code and mutations and whatnot. And you do a push. So that's done. The stuff I spent time working on for a whole week now can be done in 4 lines. So definitely keep up with new features. And I mean, a lot of times you can really save time if you know the right tool to use. So that's the story from us. We do have a few links to share with you. Aldo maintains a public repository with their tools or their cool things they're working on. Check it out. AWS AppSync documentation, it's there. You can Google it. And then Amplifi CLI. This is a new thing I just launched at this re:Invent. There's a lot of new features coming up. A lot of things I just learned. For example, the multi-environment feature was really cool because you can have multiple developers doing different environments based on Git branches. So that's already nice. So we have about 10 minutes. We can actually do some Q&A. I'm going to invite my Aldo friends up here. Feel free to ask some questions. Thank you. We'll be around if you guys are here.
Yeah.
Yes?
I didn't hear. Yes?
Do you want to repeat the question?
When we create that transaction in
Repeat
Dynamo,
the question. Repeat the question.
Oh, sorry, I'm going to repeat the question because it was a little bit low. How do you manage real-time subscriptions using AppSync? Okay, so yeah, when we create that transaction in Dynamo, the AppSync endpoint is going to retrieve a subscription back to the device, to the application. And now the application is subscribed to that queue specifically for that transaction. So any modification to that transaction is going to push a message back to the device. So you don't have to fetch anything. You're going to receive that message right away. So they say that it's an employee who created that transaction. He's going to see when somebody in the backstore already claimed the transaction, and when that runner has already bring the shoes back to the front store. So he's going to see in real time all that is happening regarding that transaction. So that's basically efficiency at the store, and that's why we needed to enable that communication. That was the use case, to make sure that our consumers, when they go to the store and they request a pair of shoes, we retrieve those shoes as soon as possible, as fast as possible.
Did you ever notice any latency issue or scalability issue for subscription?
So the question is if we notice any latency or performance issues related to the subscriptions. So not really. During Black Friday, it was really solid. The only issue was when we were struggling with the Wi-Fi connection, but we overcome this issue working together between our development team and the AppSync team. So right now, it's really stable.
Okay, so can these subscriptions, so one subscription, one connections, or can you share multiple, subscriptions through the single socket?
Yeah, that's a great question. So do you have to have a one-to-one subscription, or can you have multiple subscriptions from devices? In our case, our front employees have subscriptions to their transactions they are creating or they're requesting, but the store employees that are in the back store, they're subscribed to all the transactions from that store specifically. So it doesn't matter which employee or even the consumer can create a transaction if he has our mobile application. The consumer can just scan the shoe and ask for it. Our runners will be getting those transactions because they're subscribed to the whole store. And we can even create transactions between stores. Let's say that we don't have a pair of shoes in the store A. We can create a transaction to store B, reserve those pair of shoes, and tell the consumer, go to that store, the shoes will be waiting for you.
Okay, cool. So what's the cost for real-time subscription?
What was the
cost.
The cost?
The price.
The price.
Oh, the price?
Yeah,
So you normally pay, the price for AppSync is per call and bandwidth. So it really depends on the amount of calls you do to those endpoints. But I mean, I can say that during Black Friday and Cyber Monday, the spike of cost was not considerable. It was pretty much anticipated. It was a normal flow of cost. It's just like lambdas. You pay as much as you use them.
yeah, it's like by looking at the pricing model, it says they charge by the connections and also by the time. You keep that connection alive. So is there any concerns for using those connections, or for your use case? Is there any concern about the cost?
Not really. During we have been testing in production for 3 months or more, and so far we haven't been concerned about the cost. And like I was telling you, during Black Friday and Cyber Monday, the costs were not growing that much, not exponentially, so we're not really concerned about that.
Yeah, it's 20 times cheaper than our current vendor.
Oh, okay, cool. So do you only have the mobile? Do you have the web, web version of the same product?
Right now, it's only mobile applications that are using these endpoints, but we can totally integrate our websites too if we ever need to have this kind of, let's say that you want to reserve an item, a pair of shoes from the website, and then go pick it up at the store, you could do that. So, but we're doing that today with the website, so that's why today is only for the apps, but we could totally do it, yeah.
Okay.
I have another question over there.
Was the previous real-time database Firebase?
Yes.
And did you use React Native for those mobile applications?
No.
iOS.
Oh,
Pure native.
Swift.
okay, thanks.
Another question.
If you have a subscription on data in Dynamo, do you have to make
entitlements are based on mutations. So you can only get a subscription when you fire a mutation. And all the fields you return in your mutation are the ones you get from your subscriptions. But if you do want to, say, capture a put item, you could consider a DynamoDB stream. So use that put item, kick off a stream, click a Lambda. Lambda can invoke, we'll call it a local resolver, to fire a mutation, send it back to your devices.
And if you fire that mutation, will it go back and fetch like the most up-to-date state, or?
That's up to your Lambda function.
Question here?
Do you manage all your entities inside a single endpoint?
Yes, we have one single endpoint, and that endpoint supports multiple queries, multiple mutations, and 2 subscriptions that are the ones that I mentioned.
There is no performance limits on how many entities I can put in a single schema?
Not that we know.
I think
but,
there's a size limit
there
for the
is a-
type
yeah,
of
there's
schema. It
always
should be, there's a size limit. You can check out the AWS limit page, but there's an overall size limit for the schema document itself.
So for production ready, it's a common usage to put all the entities inside a single schema.
I mean, it's really up to you, I guess. But if it can fit, then it makes everything easier. But I mean, obviously, if you're obviously eventually grow to be much bigger.
And I think that this goes back to the discussion on microservices. Like, does it make sense to have a monolith, huge GraphQL schema, or is it better to, I think this is not necessarily GraphQL. It's more like when you look at the domain that you're dealing with, how do you break that domain to pieces that are single responsibility, as we like to say, and then now I need probably 3 or 4 microservices. Maybe you need 3 or 4 schemas, one for each microservice, right? So it's less on the schema itself and more like how you break the domain that you're dealing with into pieces that make sense or small, right? Yeah, the question.
Did you fully denormalize the data when you were putting it into into DynamoDB?
Yes, yes.
Repeat the question.
Yes, of course, yes, a great question. If you normalize your data when you're storing that into Dynamo, yes. Basically, we put everything related to a transaction in one table because it's so much faster than going to multiple tables and trying to do joins in a non-SQL database. So for sure, we had to denormalize, basically.
Since you have the data in DynamoDB, you said just one single table. So how you do the search? Just in case you only have 5 index that you can play with in the DynamoDB. So if you want to do complicated search against this table, so what's your solution for that?
Well, when we do complicated search and filtering, we use our product catalog e-commerce platform, so that product has search capabilities, so we don't really use Dynamo for complex queries. But if you ever need to do that, you can use Elasticsearch, to do that, because for sure Dynamo is not gonna be the best approach for complex queries where you need to do joins or filtering. So as you were saying, you have only some indexes that you can use, and if you use them not in a good way, you're gonna pay a lot of money. So it depends on your use case, but in our case, we're searching mostly on our backend.
And if I could just add a little bit, like if you look at the modern application, we call modern applications, there is no one-size-fits-all database anymore, right? So your application has DynamoDB for high throughput, and you can have Elasticache for fast caching data, and then you can have Elasticsearch for search, and you can have Redshift for analytics. So as you see in modern applications, more and more you don't have that single database that does everything for you anymore, right? Like even we launched a time series database just recently. So if you have a time series requirement, then now there is another database that you can use. So I think that's the future. So you're going to have those specialized databases for different things, right?
Yeah, the trade-off of that, you have to duplicate your data.
Yes, that's the trade-off.
Multiple,
Performance for duplication, yes.
And you have a trade-off to make those data insane.
Yes, exactly.
We've got
Great
20
ops.
seconds, probably one more question if there's one.
Okay. Oh, another question.
For your Lambda?
What, sorry?
What runtime do you use for your Lambda?
Node.js V8.
Of course.
So please complete the session surveys in the mobile app, and thank you so much.
Thank you, guys.
Thank you.